Imagine generating electricity from fossil fuels without harming the environment. Carbon dioxide emissions are now widely accepted as a primary contributor to climate change. Generating electricity while minimizing these emissions is key to tackling climate change, and finding a way to do this whilst providing a long-term future for Australia's key industries such as coal mining is a pressing challenge. Australia is the site for a brand new clean electricity project which aims to rise to that challenge. Located to the south of Perth in Western Australia, the project is ideally situated close to a suitable geological storage formation. It would be the third facility of its kind. 2 others are already being planned for Scotland and California. Led by Hydrogen Energy, a company owned by BP and Rio Tinto, the Kwinana hydrogen power station would use sub-bituminous coal, a form of coal that is abundant in Australia and in many other important markets around the world, such as the USA, China and Europe. Heating the coal to a high temperature and pressure turns it into a gas, which then goes through a clean-up process to remove substances such as sulfur. It is then split into its 2 component gases, carbon dioxide and hydrogen. The hydrogen, a clean-burning gas, would then be used as fuel to generate 500 megawatts of clean electricity, enough for almost 700,000 Western Australian homes. This kind of generation would provide a reduction in CO2 emissions of over 90%, as its primary waste product is water vapour. Meanwhile, about 4 million tonnes per year of carbon dioxide would be captured, compressed and transported via a pipeline running along the seabed some 35 kilometres to a subsea wellhead. It would then be injected 2 kilometres down through rock strata into a saline formation. A seam of porous sandstone rock filled with concentrated salt water that lies beneath a layer of impervious claystone rock through which liquids and gases cannot pass. CO2 is more buoyant than water, so as it enters the saline formation, it will have a natural tendency to migrate upwards. At this depth and pressure, the CO2 will be liquid. As it travels through the sandstone, some of it becomes trapped between the pores of the sandstone. Once the CO2 reaches the top of the formation, the impervious layer that caps the sandstone prevents the CO2 from rising any further. Over time, the CO2 gradually dissolves into the water in the formation. Once dissolved in water, CO2 becomes more dense and begins to sink down to the bottom of the formation. Whilst dropping down through the sandstone, some of the dissolved CO2 reacts with naturally occurring minerals to form stable minerals such as calcium carbonate. Once in this form, CO2 can never re-enter the carbon cycle. It represents the ultimate in safe storage. Storage of CO2 in saline formations is not new technology, but this is the first time it would be used in conjunction with a hydrogen power project. Australia is perfectly suited for this type of storage because of its extensive saline formations, making it possible to replicate this project across the country and safely pump its CO2 emissions underground for hundreds of years to come. Australia leads the world in developing policy and legislation to enable CO2 storage and therefore provide a viable future for its abundant coal reserves. The project at Kwinana would allow Australia to demonstrate to the rest of the world how coal can be developed cleanly. Like Australia, rapidly developing economies in the Asia-Pacific region have significant coal reserves, but also face the challenge of meeting booming energy demands in a world concerned about reducing carbon dioxide emissions. It is hoped this project will act as a catalyst for many similar projects in Australia, the Asia-Pacific region, and beyond.